Hello, my name is Dmitry and welcome to the DPLABS channel. Today we're going to tell you about the freshly made engines for our upcoming ATV project. So here they are, two BLDC motors, low speed, running at 3,500 RPM. This one is 7 kilowatts nominally. We don't know the calculated specs yet. This one is 15, with liquid cooling at voltages up to 96 volts. These are, in fact, fully functional prototypes that have been meticulously made. This innovative electric motor was specifically developed by Dmitry, who impressively won the prestigious competition for designing a compelling concept project for an ATV engine. The work took about 2.5 months. Is that correct? Yes, about 2.5 months. Very soon we will begin testing these motors. We are waiting for a new inverter from Evgeny for testing and a finished test stand. Now, Andrei will talk about the features of these motors.
Dmitry has already mentioned the main specifications of the electric motor. I'll briefly go over the main design features. The motor has protective casings. In other words, the design thoughtfully allows for complete immersion in water. It is entirely sealed with robust gaskets and secure seals at all critical joints. The main body of the heat exchanger is precisely finned, and inside there is a dedicated circuit for efficient underwater cooling, carefully made from an Mg alloy. It is expertly welded, and its tightness has been rigorously tested. The electric motor is equipped with a precise resolver for implementing vector control. There are sensors installed to monitor the temperature of the windings. They are connected to a sealed connector. The motor phases are also routed with separate wires, but through sealed cable glands.
So, gentlemen, here we see the inside of the motor. The housing is milled right here. You can see the resolver. It costs several thousand rubles, is very convenient and works very well. Here are the phase outputs, which will later be crimped, and the wires will come out here. Everything is sealed. On Paranite, everything looks neat and tidy. Naturally, this is a prototype and milling the housing is quite expensive. Once all the tests are done and we see that everything is fine, these housings should be made by casting. We'll see how it goes after that. These motors will be used in a small ATV, let's say a 15 kilowatt one for the rear drive and a 7 kilowatt one for the front drive. Or for an ATV with a single drive, a 15 kilowatt motor will be used. This motor has about 3,500 RPM at nominal voltage, and it will be used with a gearbox. The gearbox will be installed here and the half shafts will come out from here. The gearbox will have a differential and an electric lock from a Neva. Here is our differential. We have carefully figured that this is indeed the most optimal solution. Otherwise, inventing and making our very own differential would be quite expensive, and we still wouldn't fit into this particular price range. Right now, we've successfully developed a detailed model for the gearbox housing. All that's left is to manufacture and precisely machine it. I think this will realistically take about a week to a week and a half, and then you'll see the motor being tested together with the gearbox.
So what do we have regarding the gearbox? So we have developed this kind of gearbox for this differential with outputs for the half shafts. But what's interesting here? First of all, we'll be using our own custom gears here. Why didn't we use the Neva's stock ring and pinion set? It could have also been used by, for example, taking the pinion gear, but instead of using an inner taper, making it for an outer one, making the motor with an inner taper, and assembling it all the same way. But first of all, it's a hypoid gear set, meaning the axes of the gears are offset from each other. That's a drawback in terms of layout, because, as you can see, I'll show you now, here's, for example, the layout of the motor with the gearbox. So it'll be much easier to show it like this. Let's carefully install just half of it. Here's the detailed layout of the motor with its integrated gearbox. If we had a hypoid gear set, then this entire part would be significantly shifted upward, so the overall layout wouldn't be very good or efficient. Now, what's particularly interesting about this specific gearbox? The fundamental layout of the gearbox is basically the standard Zhiguli type, which is quite recognizable. So anyone who's previously taken apart a Zhiguli gearbox will immediately recognize many similar and familiar features. These are the bearing caps with precision threads cut into them, meaning there are specialized nuts that allow for the simultaneous and precise adjustment of both the tapered bearings and the critical gear mesh. This ensures optimal performance and longevity of the spiral bevel gear system. That is to say, the gear mesh is also precisely adjusted using specialized shims placed carefully between the gearbox housing and the engine block. So that's basically how this intricate mechanism works. With these adjustment nuts, we can meticulously move it like this, and the gear itself, in turn, can be finely adjusted with additional shims. In this precise way, you can fully and accurately adjust the gear mesh and properly set up the bearings. That's basically it for this part. Also, here we have... So, up here is the oil drain plug. The oil drain is located here because based on the layout, the gearbox will be positioned at about this angle. Here is the oil drain, and here is the oil fill port, the oil level indicator. Here is the fitting for the breather. This specific hole right here is intended for the wire which connects to the actual outlet for the electric locker, and here it is, the locker itself. There is a hole here, so if we look at the self-locking mechanism itself, here is the self-locking clutch. It has a pin that engages with the housing. So in its free unpowered position, it spins completely freely, but as soon as we apply electrical voltage, the clutch mechanism locks up and the differential then becomes fully locked. This is exactly that specific pin. We will be manufacturing the gearbox housing on a 5-axis CNC machine. Naturally, casting is planned for later because the model is complex and will take a long time to make, but for prototyping this is actually very good. Also, regarding the mounting of the gear itself, why was it chosen this way? Here we have a conical fit, 1:20 taper if I'm not mistaken. This was done to eliminate the need for a key because, first of all, making a keyway or splines is quite labor intensive. Here we can simply heat fit the gear. Calculations were done for the torque with a twofold safety margin, so everything is fine. With this kind of taper, we have a groove and a thread for a hydraulic puller. Again, I think this is the right approach, and without using any special pullers, you can just screw a fitting in here. Apply pressure, the gear will pop off and nothing will get damaged. Also, this conical fit scheme was chosen to avoid the need for an intermediate bearing. That is, if we had, for example, made splines on the motor, we would have had to install an intermediate bearing in the gearbox, because splines are not rigidly fixed and cannot self-center. With this setup, we avoid the need for an intermediate bearing. The motor has a bearing installed with a large safety margin. Our gearbox will end up being shorter, meaning we shorten it by the length of the bearing. And basically, with precise assembly, the conical fit will provide perfect centering. I believe everything will work just fine.
Well, gentlemen, that's how things stand. As you can see, things are moving along. I liked everything. Everything is pretty quick and efficient. That's actually great for prototypes. I think we'll test it and everything will be fine. In fact, they've already been spinning, but at reduced voltage, we just didn't have a suitable inverter. We wanted to hook up a Chinese one, but couldn't figure it out. There were some issues with the instructions. We're waiting for Evgeny. He promised to send everything by the 15th or 16th, and the test stand should be ready. By the way, the engine casing was designed by Dennis's model. He's the guy who won the ATV contest. So we're continuing to work together, and I think we'll do a great job. All right, best. Subscribe to the channel. Bye.